Hello, how's everybody doing? So, what we're working on right now is consolidation. So, I've got like a platform in the back there that's two feet by 2 feet. It might go on one of these tables, but I'm going to be getting rid of this thing right here. A lot of memories right here. And then the one before it had even more memories. But yeah, we're going to get rid of this and we're going to consolidate. We're going to get down to 2 feet by 2 feet. And we're just going to focus on one thing until we get it done. And it's going to be this basic design right here. So I was talking about this with a friend, and he suggested putting a piece of iron at 45 degrees. So that when it passes, it's attracted to the iron, but it's not like double attracted by having an opposing magnet. So I think it's a great idea. But I mean, first of all, I'm going to have to get the holes the right size or put a piece of tape around each one of these magnets so that they don't clash against the side of their holes. You can kind of hear it. That is definitely the magnets like banging. All right, so it's at 9 volts right now. I'm going to turn this on. So this bottom one is going to go down and this one's going to go up. See, we can't get it started that way. Oh, maybe not. All right, here. This is another way to do it. But at 9 volts, we're not drawing 100 milliamps yet. And it'll fluctuate probably between 100 and below that. But it rarely reaches 100 milliamps. I think that's pretty good for it being what it is, which is I can't even explain. It's a multi-filar coil. No, sir. It's not perpetual energy. It's just it's a kinetic motion device that I use for my entertainment. Hopefully you guys find it entertaining too. What is significant about this is that all these discs are spinning at the same speed. I guarantee it. Which is 1816 divided by 4. That's how much each one's going right now, 1816. And then you got to divide it by 4 because there's 4 magnets, and I don't want to mess these up and put aluminum foil all over them. Ha. Yeah. See, I'm gonna be shrinking down. What I have this huge area right here. I don't need all this. I'm gonna shrink it down to an area about this big, up like this, and this is gonna be okay. So these discs are in the Hallback array right now. So the middle one here, all the north ones are facing up like this. When it comes to this slot right here in front of the magnet, north is facing that way. Okay, south is facing down, north is facing up. And the two on the outside, when it gets to here, north is facing down and south is facing up for both of these ones. And that's virtually what it is. Each magnet that when it passes the coil here is north south the whole every time. It's not like north after south after north, which would work pretty good if I had more magnets per disc. It will kind of work. I could see it working. I just see it being just as choppy with just 4 magnets though. And I believe that I've actually tried that interchange, and it doesn't work very well. But having the iron chunk in between the magnets, where yeah, dude, that would work like really good. Um, so let's turn this off and talk about that iron placement a little more and how it would work like wonders for. See, and I got to put a piece of tape, just a piece of tape, a piece of thin tape around the sides of these magnets, just so that I can avoid having to reprint each rotor with just that. It is freaking like a minuscule, maybe exactly 0.03. So I'm thinking like a small piece of Scotch tape might work. I don't need anything thick like duct tape. That's too much. And then just stuff it. Like it'll work. But you see, when these pass, no, not a flux capacitor. It's a man. What is it? I don't know. I've heard that with the pulse motors though, because the magnets are going so fast, you do get like an interaction with time. It kind of grips time and moves it around a little bit. I don't know what the consequences of that might be. I don't know. I haven't felt anything really negative from doing this. I've been doing it for 3 years. So, I mean, whatever it is, it's not bad. Just don't inhale enamel. If you're going to burn your ends of your coils, do not inhale that stuff. That's terrible. It's really bad for you. All right. So yeah, like having a piece of iron right here instead of a magnet that attracts, have it be like half attraction, full repulsion. That I think that would be awesome. And I mean, these are not acting the way they're supposed to be acting because wait a minute, north. Yeah, they're supposed to be attracting right here. But as you can see, they are not. At least I think they are. If you go here, north is up. So north is pointed this way right now. And then here north is down. I mean, north is pointed that way right now. So that means south is pointed this way and north is pointed that way. That means these two would be attracting, doesn't it? Are they attracting? I mean, it's so hard to tell. It doesn't seem like they're attracting. That's paradoxical. I'm sorry, that isn't normal. But it could totally be attracting. If you look at it like this right there, that could totally be attracting right there. So we're going to call it, yeah, that's attracting. It doesn't feel like attracting, and like the motion is definitely not that of attracting. But yeah, when you move it this way, you can definitely tell that it's attracting. But this one moves in and starts pushing, so I don't know. All I know is it's pretty stable. It's a pretty stable build for the 4 magnets. I say you add 2 more magnets to each one of these rotors, and you can go typical north-south, total attraction, and it wouldn't miss a beat. But I'm thinking as you get up, see, like the next disc would go over here, but it would be up above this disc right here. So all of the magnetic interaction would be happening from the upper edge and the lower edge of the magnetic fields, and you wouldn't have the direct onset of it being right next to it. It'd be above it, really. So I don't know. I mean, I think the bottom line is some of this is going to have to be different. It's not going to be able to be totally uniform, like 4 magnets on every disc. But I think if we put the iron in here, it's going to move really, really fast. Not fast, but smoothly. And man, this coil, I believe, is a 24 filer. I got 20 strands. Yeah, I got 20 strands in the drive, and I got 4 strands in the trigger. And it worked like perfectly. And it's like, it just made sense. And then I can break that 20 series into 10 and 10 and run off the 2 transistors that I was running off this coil off before with it's got 8 strands of 26 parallel. So actually I had like 10 spools of copper hooked up when I was wiring this thing, and this thing's more like lintz wire. I just what do you mean? I twisted it, and it came off of 1 spool, and it's like 9 feet long exactly. Well, 9 feet 8 inches, and then each end is 4 inches. So that's 9 feet. It was done vaguely on purpose. I mean, I had to go wall to wall, and it ended up being 9.8, or 9 feet 8 inches. And so I'm like, well, I'm just going to make each end 4 inches. And it ended up pretty like perfect down to within an inch. Like the ends are almost like wrapped right on top of each other. It's just like an inch apart. And I was like, wow, that's like meant to be. um, But this one goes like 1 through 4 to a transistor, and then 5 through 8 to a transistor, and then 9 and 10 is a totally different gauge, and it's hooked in series and is the trigger for both of those. And the cool thing about that is you only need to hook up the first one to the ground, because it's a universal ground for the trigger. But you got to hook up the base side to each one that you hook up. And I believe that was explained to me several times back in the day when I was really messed up. I didn't get it then, but I get it now. Totally get it now. And I think that that's good. All right. So they kept on saying you got to hook up the base side. Each one needs its own connection, but on the ground side, you only need one connection. And now it just totally makes sense. I tried to hook up the second ground, and it totally just shut everything down. It like grounded everything permanently, but it didn't like fry anything. It just, the connection wouldn't work because it had a different path to take. That's what it is. It had a different path to take, and the path that it had to take didn't take it through any transistors, I guess. And I don't know how that happened. But anyway, I figured it out and I fixed it. It worked great. I don't think I'll ever need it to go as fast, well, it's only 9 volts, so I guess as fast as it was going just now. Well, that was more like 20 minutes ago. Here, let me turn this on again. So I'm thinking that maybe even the 6 might be good, because I got to do quite a bit to turn it on. Or maybe just a standard array, but I don't know, man. Once it gets going, it's synced up like really good, and I don't get that syncage that I do with other spreads. This is hull back array. This is all the north is facing down over here, and all in the middle it's facing up and then down. Instead of out or in, you know. I do have a picture of it real quick. I'll go grab it. And I'll show you what I thought was like really interesting on how they're interacting. But then, you know, you just look at it a little bit more closely, and it works out just fine. All right, so that's it right there. And I think, like, if anything is going to lift off, it's going to be this, if it's going fast enough. See, so this interaction right here between this top one and this bottom one is going to be north-south in the traction mode. So I don't know if that's necessarily what we want, but like straight on, like if it hits straight on, which it does sometimes, I don't even know. Wait a minute. Then it's repelling. And it's north north, south south. It's just really weird how they interact in my mind. Like, because even though they're drawn to the side of each other, they're straight on. Okay, these discs are straight on. The drawing is a little cockeyed, but that's okay because I'm explaining that to you. And then in between, at a 45, there is the so it's like this one's north south, this one's north south. So this one in the middle here is going to be north south. I think that's right. It's going to be the opposite. Yeah, of what's, it's weird. But see, if this one's going to be north south in the middle, then it's going to attract this one to the middle of these two. It's kind of really, I bet I'm losing a lot of people. But like the typical north-south array at 45-degree angle here is being achieved by the magnetic fields in between the magnets. They generate exactly what you need to, um, attract. So it's good. And it's so good because there's no like loss here at all. 22, 22, 22 within 30 RPMs, 30 magnets of each other, but all within 22,000 or 2200 divided by 4. So they're not going very fast, but they're going at exactly the same speed, which is what I'm looking for. And that has more to do with the magnetic coupling than it has to do with the power that's moving it. But that's kind of important too. But here, let me demonstrate something, because now they're synced up, right? I'm going to turn this up to 12. It's still drawing 100 milliamps. Oh, there's 200. Back down to 100. It's going to be between 100 and 200 with this one. $28. 28. Oh, 29. Okay. 29. All right. 29. Okay. So like by the time I take the tach reading of all of them, it'll go up 100 RPMs. Right now it's going probably about 31 across the board. So we get to 32, which would be right about now. And that's what? 32 is 800? Yeah, 800. 32. 32. 32. Oh, 33 on that one. Sweet, man. That is like exactly what I'm talking about. And then it'll increase and decrease. I think 9 volts is like right around 9 volts is where it kicks in. So I think it is kind of like it's a little power hungry. Not really. I mean, it is. Let me think here. 24 times 9. Uh, it's just it's art. You know, it's 3 discs right now that are syncing up. It's being run by something that I came up with today, actually. It's Litz wire. It's about 12 lengths of 9.8 inches. So, and each end is 4 inches. So the coil itself is 9 feet of, let's see, 24 strands of 9 feet twisted counterclockwise. But then I wrapped it clockwise. So now when I spin this disc, I have to spin it clockwise. I've tried spinning it the other way, it won't even start. And I think that I can rewrap it if I need to, because it's only like 20 wraps around the bobbin. Uh, so yeah, I just did that today, and it was pretty cool. It's just 20 in series and 4 in series for the drive. I mean the trigger. So we got, every time the magnet passes this, it triggers the transistor to fire, and that sends however many volts are going through and how much current it needs to send it through the 20 gauges, the 20 strands that I hooked together in series. But it's only 9 feet. It's only 20 turns, uh, 20 times at 9 feet. So, well, 20 turns at 20 times 20, plus all the twisting, which I believe propagates a lot of that wire into a smaller area. Uh, more wire into the same amount of area. Let me get up a little bit here. All right. So I actually have another platform that I'm going to be setting up on, and the shafts are going to be 10 millimeter shafts. Here, let me get the shaft and the bearing for you real quick. I think it's a pretty good upgrade. Sweet. That fits like a glove. Just need to get some oil, some light oil. Put it in the bearing. Because it won't spin on its own, basically. It needs a little bit of weight behind it. 10 millimeter bearing. I mean, I'm not expecting too much. The ceramic would probably work really good. I got to save up for that, though. And I'm willing to do that because I want to get this solid. I want to get it. And it's 2x2. So it'll fit right. This will all fit right inside of it. And then maybe get some, like when it's all said and done, whatever array or pattern I end up using, we'll put it in a case. Like it will make sure nothing ever flies out of there and breaks anything. But if we're going to do a case, we got to have a way to start it up. And it's got to be able to torque. I don't even know, man. The bearings have got to be true, man. They've got to be really true for this to get, this high. Have everything spinning. I might have to compromise a little bit on what I think it should be in order to make it what it can be. I mean, I'm going to try and make it exactly the way I want it to be, but it's all right. It keeps me going. It's only got one coil for a drive mechanism right here, but that's a pretty complicated coil. So yeah, I don't know. I guess it is kind of complicated. The only moving parts though are these discs, and there's no brain. It's just like there's no control module. The only control is the trigger coil, and that fires off. I don't know if you guys can see this, but this little transistor right here. Now I was thinking about splitting this 20 strand coil into 10 and 10 and throwing another transistor in here, and it'll probably double the current that I need to run it, because it'll be 10 strands times 2, and this is 20 strands. So I mean, I'm thinking that the amp draw at 9 will probably be around 0.3. I never had a problem there before, so I mean, they're more than welcome to come. That's not a problem for me. So, I'm gonna drop this down even farther. I'm gonna go below 6. See if it stays up at around 5.9. We'll get going real nice and slow. Yeah, I've had individuals come into the channel and they're more than that. I'll tell them exactly what I'm doing. They, they can come in and check it out themselves. They can, I have no quarrel with any of that. Still running pretty good at like 6 volts. 5.99. Yeah. Man, this thing runs, the circuit, it runs very smooth as well. Oh, there we go. We're getting a little too slow for it to remain synced up. I want to see what the difference is in speed right now between the discs. Thirteen. No, they're all pretty good. It's just the magnet banging against the side there. So put it up to 9. See, but I mean, let me explain what each one of these rotors cost. Okay. You got 4 neodymium cubes in there, which can cost anywhere between $30 and $45. And then you got 1.5 pounds, so just under a spool of PLA to make one of these rotors. They're solid. They're freaking solid. They got flywheel capabilities. They can spin on their own for many minutes. They're very heavy duty. I pray that nothing ever happens to these shafts. I'm pretty sure we'll be all right with the 10 millimeter shaft. I mean, the force it took to bend the 1/4 inch shaft was tremendous. We were going at about 2,800 RPMs, and the side blew out, and the magnet went out, and so like the magnet went that way, and the rotor went 180 the other way, and bent the shaft like in half. It was pretty intense, considering I was holding the shaft. Might have been my fault entirely, actually. So yeah, and it was pretty out there. And instead of stopping entirely, I chose to chill out with how much voltage I was putting into things. I had put it was about 18 volts into the system, and the shaft had started to yank itself out of this pegboard. And just the same sound that's coming out of these ones right now is coming out of my axial flex, but at a very higher, much more rate. It sounded like a saw, like every time I turned it on. But it ended up being a magnet, like banging against the side. Like every time it went around, it would bang against the side. It would cause it to go around faster. So it ended up banging on the side too much, and it just blasted right through. Because, I mean, the amount of force in that little motion at 2,800 RPMs was enough to break the PLA. So, I mean, it totally just broke right open. A lot bigger. I haven't found the magnet yet either. Oh, that's a bummer. So I've got this very flexible speaker wire that I'm going to turn into a pancake coil, maybe 2 pancake coils. And I think that's going to be what I do to put myself to sleep tonight. I'm thinking like this right here for a core, like the center. That'll be pretty sweet. This is only 14 gauge though, so it won't be any like immaculate 12 gauge coil or something like that. But it'll be pretty nice, I'm pretty sure, because it's a lot more flexible than the other wire that I have. And it should be able to bend into place pretty easily. Well, I mean, just that's going to work. Yeah. All right. So that's going to slow down synced up too. It's going to remain synced until it stops pretty much. It'll be loud at the end, but sweet. So since I only need one layer of this wire, I think that'll end up being a pretty good center. There we go. No, I got one rotor that I wanted to show everybody. It's pretty cool. All right, let me grab that. It's right here. Now it's got a blue undercarriage. The center of it is glow in the dark PLA, and the top is gray. So this thing is pretty cool. It's got gyroscopic magnet holders in it. So like when you spin them, those parts in the middle spin the opposite axis. That's pretty dope, I think, man. That's awesome. But like I said, it's more on the level of being art than it is being practical electronics. I don't even know if this one will light this up. Never even tried it yet. I would assume that it'll work. I have an idea since it's so I just turned it all the way up. See, it's that 26 gauge trigger strand that these magnets are struggling with. The spacing between them is a lot different, and they're not the cube magnets, so they're not as strong. But I know that this one over here, this one will work. This one has worked. But I haven't tried this little one yet. Hmm. Yeah, this coil might not be able to push this one. I don't know. And I will prove that it is the strength of the magnets. And these are N52s in this rotor right now. And then what I'm going to do is I'm going to hook up the parallel coil with the two drives. I'm going to hook this up and show you that, I mean, just having two strands of 32 gauge is better than having four strands of 26 when it comes to picking it up. Let's try spinning it the other way. I mean, So we'll put this off to the side for now. Put it right there. Just a second. That's all right. You can already tell that that's kind of working, right? Yeah, that's on. See the difference? Those were just little flat ones. Hi there. Doing good, Matt. How about you? My bad if you've been sitting on that one for a minute. All right, so oh, do I really want to set this one up? You know what? We can try. Just put this one out here like this. And we need 2 more transistors to hook that up. I'm just, I just made this coil right here today, and I decided to try it out and show everybody what it does, what it's capable of. And I was just about ready to hook up 2 more parallel coils to this rotor. And then, but all on the same power supply, basically. Right. We're going to hook them kind of up at the same time. Just need to find, well, they're right here, so we don't need to look very hard. Yeah, that looks good. Sometimes it's really hard to see these things. Wow. I wonder how these things get so coiled up sometimes. Sometimes it just blows my mind. There we go. So this is going to clip to the same one. It's number 9, okay, in this coil. The 9 and 10 are both 32, and they're both linked in series. So is this one? All right. What is this one going to? I think I want to flip it around and use it. It's got a diode in it. So I'll clip that to here. And we're going to swap it around. Have it flow to the ground. And this will go to the negative end of the trigger over here, so number 10 on the other side. So both bases are hooked up to the one side and the dump is hooked up to the other side. Right. Now, this is what it was originally for. We're going to take the power from here. This transistor, the collector, we're going to sync to the collector. And we are going to aim it the other way, away from the collector. To the next collector. Now we got to do this one more time, kind of in series. All right, so right here we are. Yeah, I can move the camera a little bit, but it's going to cut other stuff out. So yeah, let me do that real fast. Well, I could take it down, but I have to put it together first. I'm not going to take the camera off the tripod right now. But I will show you and try to explain it to you after I've done so. All right. So we got halogen bulbs, 120 volt halogen bulbs that we're going base to collector without a diode. It is acting as resistor or resistance. And I find that it's pretty much basically all you really need to make it work. But it is almost definitely a necessity. Oh, all right. So now we got our oh, dude. See, I gotta change it back. All right, because now I'm not even in the picture. My fault. We'll get some close-ups as soon as I build it real quick. So this is one right here. So we go emitter to number 1 on the second coil. And I believe that's already grounded. All right, that's good. Now we got another light assembly thing, just 2 clips and a light. We're going to hook that to the next transistor, which is fell down here. No, that's not it. Where did it go? Oh, right here. So we'll put our resistor on. And it's going to be like a 1, 2, 3 scenario. That's what I like to call it. So you got 1 on the base, you got 2 on the collector typically, and then you got 3 on the emitter in the single coil spread. But I mean, when you're doing more than that, see, now this second one that we did, we're going to clip an output to the collector. All right, this is a really long cord, so I don't think I want to commandeer like the whole thing. I just want to get both ends. Okay. Actually, I just want this part. The long part can stay over here. Just giving our third transistor some power. All right, now I think we want the long one. Right. Want to go emitter to number 5. Well, actually, we want to go number 4 on this side with the long one. And we want to ground it, so we got to do this because there's so many attachments to that one part already. We got to make sure the energy doesn't fly back. Through any of its various channels, which are now numerous. And then we just need to hook up the last one. Go figure. We got it though. Came so close. To not having any spills. 5. Here it is. Now we need to hook up 8. We need here it is. Wow, it was surprisingly easy to get all this stuff apart. Amazing. All right, so now we just need to do 8. We'll see if I got this right. Well, I think the power generation, well, the power distribution is going to be equal, like across the board pretty much. I mean, if I did this right, it should be. Here we go. It's either gonna. It's all right. Something. It's either transistor, but let's see what it is for sure. God, I really hate these because they're so heavy. And they've always wanted to just slide off the table here. And I got to get them sitting a certain way. And when they finally get sitting that way, no, they're just all touching everything. All right, so it is this third transistor that is bogus. Well, that can't be. It's just that's the new one. Maybe it's because of how it's touching. It's really easy to fix this if you just. There it is. Let's give it a whack. All right, let me get the camera off the tripod real fast. All right, so let me get a zoom in on this coil real quick. So it's that big. It's like 20 turns. That's it. That's it right there. And we got the bigger one, which is 10 file of parallel 20. There's 826 and 232. All right, now let's get to the cool part. All right, we got the 4 plugs going into that coil right there. 2 for the trigger and 2 for the drive. There's a transistor right there. It's plugged into this heavy duty plug thing, and it's cool. See, we got ends on this side, and then we got ends up there too. So we got 3 on the emitter, which is the red one. We've got 2 on the collector. One is for the light, and the other is for the power in. And then we got one up here for power out on the collector. And then we got one for the base. Now the power out on this transistor, the yellow one, goes down here and around and up and goes into the collector of the next one. Okay, so that's how it gets its power to operate, is from that. I call it the extension, an SG extension. But I don't think it has anything to do with SG now. It might, but I don't think so. I think it's a naturally occurring thing. Well, you got to do it on purpose, but it's really easy once you figure it out. And thank you for Peter Hall Effect 2.0. Thumbs up, man. What's up, Mike? So basically, we have all 3 of these transistors. This one, and that one right there. And they're all hooked up to these 2 coils right here. I might have had those backwards. That's all right. All right. Well, that's pretty cool. There we go. And that's a hallback array in the magnets. So it's north south, except the north isn't facing out, it's facing up. Let me show you exactly what I'm talking about. It's like they're going like this, north south, instead of like this. So I guess the way I have it set up, it's not doing too much more power. Let me try something. Because normally it works pretty well when you dump the other end of the trigger coil into the emitter of your transistor, but it's hard to figure out which transistor to do that with when you got two of them that are hooked up the way they are. So I originally just had it dumped into the ground. I think that'll work best, actually. I'm going to switch that back. All right. Yeah. So I'm going to make this coil tonight. It's 100 feet. I'm not going to make it 100 feet, probably 50 feet, and I'll make two of them. Oh, well, I've been able to generate some power using a pulse motor. Yeah, I'd say it's pretty viable as a method if you can streamline its design. Gotta come to a conclusion on what the design is going to be, and then everybody can pool their resources and make, practical one. Because I would say it's very fun and awesome, and experiments are cool, but it's not a cost-effective way the way I do it. There'd have to be a lot more involved for it to come even close for me to make a cost-effective pulse motor. Right now, it's just for me to explore and have fun with the magnets. You're more than welcome to come and join me in this journey, and that's why I'm doing this. You know, I'm not really doing it to for the views. I'm not. I'm really not. Hey, what's up? I like views. Views keep me stimulated, but I really like sharing with people what I'm doing. And just because I don't have like a goal that everybody else has, doesn't mean I don't have a goal, really. My goal is to have fun and to learn as I go. And that's my goal, and not to replicate what anybody else has done, intentionally anyway. And hey, love, love. All right. Um, so I really like appreciate people's like opinions, especially educated opinions. I love educated opinions. I don't really like, people saying, "Oh, yada yada yada," with nothing behind it. I mean, it's cool if you got something to say, but please back it up with something that's substantial. Not some third party regurgitated, you know, something from somewhere else that happened 15 years ago. I mean, yeah, you want your 60 seconds back. I'm sorry. Did you really even have to say that? I don't know. A lot of people, they feel like they have to say stuff like that. And now we're getting to the point where I like don't have too much more to show you, and it's like getting towards the pillow talk time. About to unwind here, unload and unwind. I do hear you. Ay ay ay. So not anybody in the, but I'm going through a lot right now. So I got my wire here, and it's going to keep me occupied tonight. Um, I'm going to make a pancake coil with the center about that large. Maybe I should make it smaller. I don't know. But you can see that that thing is still spinning. Hmm. I wonder. This should be able to go through the cycle without actually needing to run that part of it. So let me turn this on. This will see whether we have anything over here hooked up in with. I guess. Can't really tell. Doesn't sound like it. Not at 12.3. Something's not right. But it's definitely something I could hook up for the next one. So we're at 25 volts right now. I'm thinking I need to ground that trigger some other way. Oh no, we're drawing amps. That's weak though. Huh. We'll have to figure that out. So it's just running very poorly. But I mean, that's what I get for just spur of the moment doing stuff. I'd like it to work out, but sometimes it just doesn't. Oh, it looks like that's starting to grip a little bit. I unplugged the third one. I don't know if it's going to grow, but it looks like it's going. Hell yeah. I'm going to see for real quick. I don't know. I'm moving that one in will make it work. But I'll figure that out so it'll run. So that halogen bulb down there is lit. And that's for this transistor. Now let's look at the other ones. No. There's the other one. No. But look at it going with the little coil. Little coil's taking control right now. Turn that off. All right, I'm going to go put this up on the tripod again. I'm going to try and get that running. All right, I think I may have found. No. Hmm. So I'm thinking, so I'm going to back this out one more time. So that was a wire connection. So I'm thinking it is the ground of the trigger coil. Maybe we take this. Not like that. um, yeah, this connection here is really awful. So that means, could that still be right there? Maybe. All right, one more time. Man. That might have been it right there. God, it's so fragile with these damn clips. There it is. Okay, so there's now one more thing I can do. And that is put this here, and then take one more and connect the ground to both of the transistors, which didn't work the last time, but let's just say it won't work this time. I say it won't work this time, but we're going to try it. Well, I want to see what lights are working, so we'll turn it up to 15. No. That first one's on. But it should be working. No, the lights are still off. All right. I'm going to have to do this over again. Hello. Doing well. I might get a little crazy tonight. Don't know. Try to keep it pulse motor related. All right, so we're going to start over from scratch. Nah, just kidding. Just from this first extension loop. I really don't like these. No, I don't mean these things. I mean like all the weight that is being placed on these things so they don't stay where they need to be, which is, of course, why I tried breadboards. All right, so we're going to start and we're going to make sure that one's still working. All right, thumbs up. That's good. Sweet. All right. We're going to get down to this one. I think, no, because this is a different trigger. Oh, wow, that's what the whole freaking issue was. I think, anyway. Is that it ended up upside down and I didn't realize it half the time. So we're going to do one of these circuits. We're going to make sure that it is going to work before progressing. All right. I think I'm just going to put these on the ground. So I don't want to hold them anymore. All right. So we're going to clip power on. Diode. Collector. I really don't like these. I'm telling you, man. Doesn't give me a fair. Okay. This is the part where I get confused. The ground. Yeah, it's going to go right here. To the emitter. And the base. It's going to go to number 9. 10 went to there. Now, use this blue one to go to the power like I did before. So that goes emitter, or to the coil, not the power. Number 1. Four. All right, I think we're all hooked up now. Oh yeah, that's in. Sweet. All right, yay, it works. Nice. ZVS, that's Tesla coil, correct? Or is that like a circuitry for a Tesla coil? That's TC, that's Tesla coil. So yeah. Woo! Way to go, John. Anyway, this works. It finally got it to settle down a little bit enough to work. So we got all this hooked up on just that one power supply, so that's good. I would hook up the third circuit, but I don't know if all these transistors are functioning. I think this one works though. Yeah, I'm kind of just into that. Haha. Specs, I see. All right. See, now this one, I don't think you have to hook the ground up to the transistor like you did. Well, I hope that's enough end. Didn't look like it was enough end. But if there's any problem, I'll know that that is where the problem is coming from. Now, I believe that all other ends are good. 120 watt halogen bulb. All right, I believe that's it. Just make sure that I have that ground hooked up. Oh no, number 8. And that is a grounded ground. So tonight I'm going to build a pancake coil with the speaker wire up there. And then I have I believe it's a 1.5 inch PCV that I would like to turn into a Tesla coil. If it's not good, I'd like to know that. About, I don't know, 1.5 feet long. And it's 1.5 inches in diameter. The wall is about, I don't know, I'd want to say 1/8 of an inch. Oh yeah, that's right. We want to do the ground. Second one. Okay, so that looks like it might be a bad transistor. Okay. See if unhooking that power will solve the situation for now. And it does. Okay, so it is a transistor for sure. Oh yeah. Yeah, wow. That sucks. Oh, I got you. Yeah, man, there's a definite sweet spot. Just a phrase. All right, so I'm thinking that's 100 feet of speaker wire right there. I'm thinking I'm going to make 2 coils of 50 feet apiece. Is that good, you guys think? For right now, with that wire, just to make 2 pancake coils that could interact with each other? Or should I go like 25, 75? I don't know. I'll figure it out. I'll do what feels right, what looks right. Because I'm sure that the pickup coils are supposed to be a little bit smaller than the drive coil, so to say. Mm. But I'm really liking this now. All right, I'm going to move that little coil up in there. I'm going to move it down to 12 volts. We're going to take off for a little bit. Blast off. Here we go. So we're already up to 300 milliamps. That's how I know it's working. Now we're down to 200. That's more like it. In between 2 and 300. And it makes sense mathematically too, because it's 20 times 9 of 26, which is, oh, come on now, 18, 180, 180 feet of 26 gauge. And then over here is turns of 8 strands of 26 and 2 strands of 32. All right, we got a little bit of battery left, 23%. So I'm definitely going to hook up the third transistor. Got to get a new one out of the box here. Then it'll be even more milliamps, but that's okay because I'm just messing around. Right now we're at 200 milliamps. And I think it's drawing so much because of the second circuit is a lot smaller than the first circuit, which is 180 feet, or maybe it's longer. I think it's because it's longer. Might actually be the same size when I come to think of it. But let me think. No, the second drive is way longer. This is 4 strands of 666. But honestly, I made it so long ago, it's either 333 or 666. But I know it's one of those two. And just, it looks bigger to me than this other one over here, which is, I don't even know. It's very cool. It's got a nice little punch to it that, I wouldn't normally see in other places. Because the Litz wire, the twisting of the wire actually compounds the wire, so a lot more fits into a smaller area or the same area as a parallel wrap. You just this one, the twist is very tight, so I twisted it almost to the point where it would snap, and it was a little ununiform, but I believe that's okay. It's demonstrating to work out pretty well. And I'm figuring the tighter I twist it, the more is going to be in that smaller area. So that's all I was thinking about when I made it. And then, I mean, the dimensions of 9 feet just kind of fell into play when the wall to wall was 9 feet, 8 inches. And then I made 4-inch ends so that I could work with them a lot easier. You know, it all worked out to be 9 feet. All right, I'm going to see if the other rotor will work now. It's an 8-inch rotor, so I got to back these out. Hopefully the wires don't get crossed. Now this is a collab rotor. Dollaraf designed this rotor. And I printed it. If you want to work a collab like that, just hit me up on my Discord. Want my Discord, hit me up on my email. It's all on my channel. Go to the About page on my channel, and my email's right there. But we're going to talk for right now on Discord. I don't know. Trying to spin it fast enough so the magnet passes enough times quickly enough so that it'll turn on the transistors. But it's weaker magnets and they're farther away. But I hope this one will light up. I don't know. I don't know what to do about that. I do know it's the magnets though. I want to redesign this rotor to be exactly the way it is, but with the cubes. So like these gyros, you can see when you spin them with your hand that they gyro. They spin, both axes spin. So that is pretty cool in my mind. It's just shocking that that's not fast enough to get it going. Well, you can't win them all. I think if I put this circuit first, I had it running off of this one before, that it'll be enough. I'm going to turn it up once, try it again. There we go. 18, about 17.8, and we got a milliamp. Yeah, I don't know. Can't really tell. I don't think it is working though. But it is cool. This rotor is pretty nice. I got to borrow soap. It's pulse motor mayhem, bro. Well, let me turn it up. Let me just turn it up here. I don't know. Yeah, no. And it's amazing how these magnets won't hit it, but the cubes hit it very well, and bigger magnets even better. Hmm. So, like, these aren't even magnets north or north south facing outward. They're facing upwards, like that. That's probably why it's going as slow as it is, because it's not north out, it's north up. Not facing up directly, but up is in, I'll show you what I mean, orientation. So you're looking at it like this. Up is facing up that way. When you're looking directly at it from the magnet, you are facing left. North is left. South is right. Mm. That's so weird. I don't know. I think we're going to be done for right now because this stuff keeps on coming undone. Unless this isn't on. It's not on. That's what it is. There it goes. See, I'm getting tired anyway. See, that's what happens when you try to run it without the power. You know, the whole, what I consider to be free energy is running something without a power supply. That is free energy to me. I know that there's other meanings for free energy, but not. I don't consider them to be legitimate meanings. They're just, you know, it's like somebody made it up yesterday kind of meaning. Uh, I do believe in energy that doesn't cost much. It costs the amount it costs to run it, and that's it. I believe in that. And you can get so much more out of it than you put in it. I believe in that too. But I do not believe that you can get something for nothing. Even if it looks like you can, if you can do it without a battery, a capacitor, or a power supply, I'm with you on that. And that is the most miraculous thing I've ever seen in my life. And I don't care either way, up or down, whether free energy is real or not. It doesn't bother me either way. If it is, let's hurry up and get a move on with it so we can make a practical use of it. I think we may have already done that on several levels, especially computing. Computing is one of those levels where we've increased the leaps and frickin' bounds in the past year. Awesome. So 7.5 volts for the 2 coils. We'll run at 0.00 amps at 7.5. 7.51, you're going to get a milliamp, 100 milliamps drawn. It's a little high, but you know, it's a tiny coil. Well, I mean, thank you, everybody. It's been fun. We got the 2 coils functioning. I wanted to get the 3rd circuit in the 2nd coil functioning, but I don't want to be busting out my transistors with my head being the way it is. I want it to be clear. I don't want to blow 3 transistors trying to hook this up, so I'm going to take it easy. But these are the new shafts. Check it out in comparison. Like twice the size, almost, like in diameter. It looks like this was a really long 10 millimeter rod, and they cut it into several pieces. As long as these bearings slip on there nice and good, I'm okay with it. And I got some phalanges that the bearings will rest on once I get them on. And then, see, it'll be like that. It'll be awesome. I mean, if everything goes the way I think it's going to go, it should be really, really cool. My new base. I'm going to show you guys real quick what I'm talking about. That's it right there. So it'll fit the 3 rings in there, and it's big enough. And I'm going to just shrink down to that size and keep it really nice and tight with the 10 millimeter shaft. And then I'm going to measure out where all the other shafts are going to go. I'm not going to have a nice smorgasbord of pulse motor going on that thing. All right, well, that's good. Cutting it really close. I'm glad you all have hanged out for so long. Friends and other people alike, I really appreciate you. Thanks for coming in. Peace out. Have a great rest of the night. I'll catch you guys in the near future, and we'll have a blast. Thank you. Again, peace out.